problem. Remember here we're doing kind of a two-stage situation. First we're going from plant to warehouse. So here we have a, what is it, 3x4 matrix in this case. So I'm going to draw my little 3x4 grid here. Now, something that is true of all of the problems on the exam is we have route restrictions. Where for example, plant A doesn't ship to every place. So in order to show that route restriction, I'm simply going to color the cells that I think are available routes. A, for example, goes to 1, 2, and 4, but not to 3, so I don't consider it. B goes to 1 and 3 alone. Go there. C is 2 and 4. So those are the potential routes. Next, I'm going to copy a cost grid down here. Basically, these same things will be the cost of shipping. And you'll notice the costs are listed in this little table over here. Okay, so we've entered in the cost off of our little table here. Now this is plant A, B, and C. Going to warehouse Roman numeral 1, Roman numeral 2, 3. Now there's two basic constraints. Let me just kind of squeeze this a little bit. All right, there's two basic constraints that we're going to have to deal with. The first one being the capacity of each of these stores. So over here I have, well, let's call it shipped. That's what gets shipped, and here's the capacity. The capacity is given to you. 70, 65, and 80. The shipped out is simply going to be the sum of the rows. All right, on the warehouse side, I'm only interested in knowing what was accumulated into the warehouse. So I'm going to just add that into the warehouse. And then lastly, I have my objective function. And on the objective function, I need to include the sum product of this first stage, which is shipping these items at these costs. All right, so that's stage 1. These have to be less than or equal to that, and I'm figuring out how much is coming into the warehouse. Now, before I go much further down the way, there's a check that I always need to do, and that's to determine, is there enough available material to satisfy demand? And if I add up the available material here, I come up with 215 units available. If I add up the demand, I come up with 233 units of demand, which tells me what? There's a shortage. The only way to determine the shortage, well, there's several methods, but the method that we've discussed is to implement a dummy factor. So I'm going to come in here and do that to begin with. Remember, the dummy is capable of shipping to all of the destination locations. And the capacity of the dummy is basically equal to the total capacity of the product to eliminate route restriction. All right, lastly, we have to make that the most expensive, so I'm going to put $1,000 into that. So this is the more expensive choice. And then finally, I need to update rather the objective function to contemplate that shipping cost. So that's the full-on stage 1 of the shipping process. Questions about that stage? All right, next then we're going to roll over here and do stage 2, which is shipping from the 4 warehouses into the 7 stores. Pardon me while I just do a little recycling here, okay. So basically I'm going to have a 4 by 7 matrix. And again, I have route restriction. 1, for example, can only go into 1, 2, and 4. 2 can go into 1, 3, and 6. All right. 3 can go into 4 and 7. And then finally, warehouse 4 can go into 5 and 7. So there's the warehouses, here's the stores. All right, the demand at the stores is given. So here here we've got what arrives at the storage versus the demand. The arrive is simply going to be the sum of what it gets from all of the various warehouses. That formula goes across. And then the demand that will be given in the problem. Okay. And then remember, I have to accumulate out of the warehouse, which is the sum of the row in this case. That shows me what's being shipped out of the warehouse. And then to accommodate this, I basically need in minus out equals 0, which what came in, let me just flip over here, what came into warehouse 1 right here, minus what came out. What came into 2 minus what came out. 3 minus 3, and lastly 4 minus 1. So these will be exactly equal to demand. This will be less, or exactly equal to 0, excuse me. I also need to update the objective function. I may have shipping costs involved, so I can just copy this grid down. So shipping costs are listed here, so I'm just put those in real quick. So we've got this new cost grid. Remember, the color coding thing is not necessary. I just like it to help us see what's going on. At the end of the day, we can update our sum product or objective function now. Remember, we had the sum product of stage 1. I'm simply going to add to it the sum product of stage 2, which are these things times the corresponding. That is the complete formulation for this problem.
And the cell completely with this variable area, correct?
As long as that helps, which we're about to see how I might use it. Alright, so there's the full problem. I go into solver. I'm going to take that objective function and minimize it by changing cells. Here's what it is asking about. Basically, by holding down the control key, I do a hunt and peck situation where I highlight only the available yellow cells at stage 1, and then I come over to stage 2 and once again highlight only the corresponding yellow cells. The idea behind this is since the blank cells are equal to 0, the sums and rows and columns, 0 plus 0 is nothing, and as long as I don't change them, they'll remain 0 and not affect the output. Alright? Our constraint, what gets shipped out of each factory has to be less than or equal to its capacity, just like in the shipping problem. What arrives at each end destination needs to be precisely equal to the demand. And lastly, what goes in minus what goes out equals 0. And in this case, I type equal and literally type the number 0. Under options, I want linear model non-negative. And remember, if we have a more robust computer, we can expand the capability here a little bit so that it gets to a better answer by upping the number of iterations that it does. But nonetheless, I hit solve, and it says solver could not find a feasible solution. A goes to 1, 2, 4, goes to 1, 3. I remember doing it on purpose. Notice that the in minus out situation does not include the dummy. Remember how we added the dummy later on? And this is something that I've seen on lots and lots of tests. People insert the dummy row, but then forget to update the flow of the product to include the dummy. Notice how I'm not including the dummy. So what that's telling me, the reason it said it couldn't solve it is there's not enough supply to equal demand. Notice that now that I've updated the formula to include that, it solves without issue. And in fact, how many dummy units could it ship? 18 millimeters, all right? Remember, we can solve a couple of times, and it's going to be the same answer. So let's look at the yellow boxes, which is what the test will always show for answers. If I want an answer from you, there will be a little yellow box next to something, what is it? So the first thing it says is total shipping costs. What are the total shipping costs in this problem? The objective function, but what's the problem in the objective function? It has 18 units of fake material flowing through the system. So I have to back those 18 units out of the system and then corresponding cost. So where's the 18 units at? They're right here, right? So I could just delete them. Is this the right answer?
No.
No, because if I come over here, notice what's happening. We're shipping 16 too many units out of warehouse 1 and 2 too many units out of warehouse 2. So what this basically means is I'm going to have to delete 16 units from this side of the equation as well. And where am I going to delete rather those 16 units? From the most expensive route. Well, there's no units here to delete, so that's not a consideration. So where would the fake units be sent? Store 1 at $400 a unit, or store 2 at $300 a unit? Store 1. So I need to come in here, take that 31, and knock it down by 16. Notice when I take that out, that my in minus out now balances again. All right. Next, I come into warehouse 2. There are 2 fake units coming out of that warehouse. None of them went here, so it either went to here or to here. Which one? This one right here. So I'm going to knock out 2, which basically takes it down to 22. Notice that this now in minus out equals 0. Also note that if I look at the difference between what was demanded and what arrived, I come up with the shortage. That all should balance. We had 18 fake units, 18 units of shortage. I floated through the system, pulled it out. Now, my actual total cost is was $178,300. You just type in full credit. Then it says, what was shipped from factory B to store 4? Well, let's look at the route. B to 4. How can I get here? Well, I could go up to warehouse 1 and then down, right? Or I could go to warehouse 3. No. So if I come over here, where did store 4 get its merchandise from?
3.
Only warehouse 3, 22 units. So if I come over here, how many units did warehouse 3 get from B? 22 units. So 1 unit went here. So what's the conclusion?
22.
22. See how we can track that through the system? How much was the total shipping cost from from factory A to warehouse 1? A to warehouse 1. How many units shipped?
0.
0 times the $400 cost. Conclusion 0. Now just pretend like this is said from A to 2. How would we come up with it? 70 times 300, 21,000. All right, let's keep that photographic memento. All right, then how about this? C to 1. That's pretty much just this route, right? There's no other way to get from C to 1, right? So C said how many to warehouse 2? 0. So right there, I know it's the mono. 0. That's pressure. The shipping problem is identical to this, only what? It's just stage 1. Storing factory store, that's it. There's no in minus out equals 0. Other than that, the problem setup is exceedingly similar. And similar question, what's the total shipping cost? How much do you ship from one place to the next? The biggest 2 problems that people have on the shipping and transshipping is failure to recognize a demand excess or a shortage in supply, where I have to implement a dummy. That's mistake number 1. Mistake number 2 is once I solve the problem using that dummy information, I fail to adequately extract the dummy units out of the problem to get the actual what's going to take place.